When you look at a bowl of shellfish, you might think dinner. Sarah Dudas thinks work.
Okay. 26.
I've done too many dissections,
52.
done too many spawnings.
78.
I can't help but look at the steamed clams and they're open, and I'm inside look, oh wow, that one's really fertile. I can see all the eggs in it. You know, these are comments I make at dinner parties.
She's a shellfish biologist, and lately she's pointing out something else in those shellfish.
They're all sorts of different colors. They're very small, all sorts of different shapes and sizes.
Out of relatively new materials we familiarly call
Plastic,
plastics.
microplastics.
Last summer, she and her students collected thousands of clams and oysters across coastal British Columbia.
The task of starting to process those samples began.
They used chemicals to break the shellfish down, filtered out all the biodegradable stuff, and looked at what was left behind.
We're finding most shellfish have plastic in them.
So when you eat clams and oysters,
You're eating plastic as well.
her study was funded by the Canadian government and British Columbia's shellfish aquaculture industry. They wanted to test whether shellfish farmers have been contaminating their own crop.
Shellfish aquaculture uses a lot of plastic infrastructure. It's one of the tricky things is really trying to figure out the sources of the plastics.
She turned to Peter Ross. He's been studying ocean pollution for the past few decades.
I try to let the ocean inform us and guide our research priorities. We've long known that debris and litter can be a problem for sea life.
A few years ago, Ross began studying the world of plastics that don't show up in photographs, sampling water off the Pacific Northwest coast.
And we were floored. We documented widespread microplastics from 200 particles per cubic meter of seawater all the way up to 9,200 particles per cubic meter of seawater. Large numbers. We see little fragments. We see microbeads
Microbeads.
from toothpaste and facial scrubs. We see nurdles.
They're just resin pellets that can be melted and formed into whatever.
We see polystyrene beads.
Like I went to the dollar store at Christmas and they were selling styrofoam beads as fake snow. Why?
But 80% of the particles of microplastics that we're running into consist of fibers. We see loads and loads of fibers. They're being readily ingested and consumed at the bottom of the food chain. So we're finding them basically in every species we look at. We need to know where those fibers are coming from.
So lately, Ross's science lab is looking more like a crime lab.
Okay, so we found this little particle.
He's using forensic technology to trace these fibers back to their source.
We're just going to pinch that down there and confirm what they are and where they might be coming from.
It can calculate a particle's chemical makeup and cross-reference it with a global database of materials.
So if we look at, say, the second and third ones, which are commercial products,
It's a good match.
1, 2, 3 beautiful peaks.
Good match. Nylon fiber. Yeah.
So this is kind of nice because
Yeah.
they're all nylon, and you've got the data.
They've also identified plastics like olefin and polyester, pointing to the fact that many of the fibers ending up in the ocean are starting their journey much closer to home, probably in your home.
It would suggest that fibers are coming in part from our own clothing.
One of Canada's biggest outdoor clothing retailers is taking notice.
Just about all the fabrics we use are either wovens or knits, meaning that the fibers are kind of mashed up together in a weaving process or in a knitting process. Over time, more and more of them work loose as part of the washing cycle.
That means a single load of laundry can create thousands of microplastics. And filters on washing machines and wastewater treatment plants aren't built to catch fibers that small.
Those are getting flushed out into the water system.
Crook says better filters could be one solution, but better clothing is another.
Working with suppliers to find new materials and then testing them against the old ones to understand how they fail, where they fail. We don't know exactly which materials are degrading at which rates and what's out there in the water systems right now. That's part of what we're looking to the science for. The more we know about how this problem's manifesting in the water, the more we can go back and tinker and try to improve the materials.
He hopes the data will start a conversation within the global apparel industry and beyond.
Yeah, it's a society issue.
It was indeed lucky for us that the men of plastics had labored so long and well.
Ready to bring new beauty and comfort to your home and add charm to your peacetime living.
When we look around our home and our work environment and our cities, we see plastic everywhere. My concern is that we've got this latent reservoir of products that is basically a future supply of broken down microplastics. And those microplastics are in turn ingested up into the food chain.
So should you be concerned about being part of that food chain? Scientists don't know yet.
Literally every day we're learning more about the risk that those microplastics might pose to the animals that are eating them, us included as well.
But they do know how to avoid seeing the worst effects.
Reduce plastic. Reduce our use of plastic.